Right now, as you read this, a machine is falling through the dark about 15 billion miles from the chair you're sitting in. It is older than most of the people who now operate it. It is colder than anywhere on Earth has ever been, and by nearly every calculation ever run on it, it should already be dead. It should have frozen solid decades ago. The fuel in its lines should have turned to ice. Its circuits should have cracked and gone quiet. Its voice should have faded somewhere out past the last planet unheard and unanswered, drifting into the space between the stars. And yet, at this exact moment, a radio dish on Earth is straining to hear it. A signal thinner than a whisper is arriving, after crawling across the emptiness for almost a full day. The machine is still talking, still measuring, still sending word home from a place no human object has ever reached. Its name is Voyager 1. It left Earth in the autumn of 1977, before the personal computer, before the internet, before almost anyone alive today can clearly remember. It was built to last 5 years. It has now lasted 49. Think about what that means for a moment. A device engineered in the 1970s, running on less electricity than the bulb in your refrigerator, is still doing science in interstellar space. Not a photograph of it, not a model of it. The actual spacecraft, still awake, still working, still ours. But that is not the part that should stop you. The part that should stop you is this. Everything about deep space wants that machine to die. The cold wants it. The distance wants it. Its own decaying heart wants it. And for almost half a century, a small group of engineers has been fighting all three, one crisis at a time, to keep a dying probe from going silent. This is the story of how they do it. It involves a computer that started speaking gibberish and had to be rewritten from 15 billion miles away. It involves a set of thrusters that were declared dead for 21 years, then brought back from the grave against the risk of an explosion. And it involves a countdown, happening right now, that no engineer on Earth can stop, only slow. To understand why any of it is so hard, we have to start with the cold. Space is not just cold. Space is a kind of cold that has no bottom to it, a cold most people never really picture correctly. Out where Voyager 1 is now, far beyond the warmth of the sun, there is almost nothing to give off heat, and almost nothing to hold it. The sun from there is just another bright star, too distant to warm anything at all. A spacecraft in that environment does not gently cool down. It sheds heat relentlessly, radiating its warmth away into the black in every direction, and nothing pushes any of it back. Left alone, its temperature falls and falls toward the temperature of deep space itself, which sits at more than 270 degrees below zero on the Celsius scale. And here is the problem that has haunted this mission from the beginning. Voyager 1 steers itself using a liquid fuel called hydrazine. That fuel runs through thin metal lines to a set of small thrusters, and those thrusters fire in tiny puffs to keep the spacecraft's antenna pointed back at Earth. Without them, the antenna drifts away from us, and the signal is lost forever. Now here is the cruel detail. Hydrazine freezes at around 2 degrees Celsius. Read that again, slowly. It freezes at a slightly warmer temperature than water does. The exact fluid that keeps this spacecraft aimed at home turns solid before ice even forms in a glass on your kitchen table. So the danger is not some exotic space hazard. The danger is ordinary freezing. If the fuel lines on Voyager 1 ever get too cold, the hydrazine inside them turns to slush, then to a plug of ice. The thrusters starve. The spacecraft loses its grip on Earth. And the most distant object humanity has ever built goes dark, not with an explosion, but with a quiet slide into the cold. The electronics have their own limits too. The delicate components that record data and run the radio are only rated to work down to about 50 degrees below 0 Celsius. Push past that, and circuits misbehave, then fail. So the whole machine, fuel and electronics alike, has to be kept above a temperature that deep space is constantly trying to pull it below. Which raises an obvious question. If space is that cold and the sun is useless out there, then what on earth has been keeping Voyager 1 warm for 49 years? The answer is the strangest and most beautiful part of the whole design. Voyager does not fight the cold with the sun. It fights the cold with a piece of slowly dying metal buried in its own body that has been generating heat every second since before it launched. To see how that works, we have to go back to the beginning, to what this mission was actually supposed to be. In 1977, Voyager 1 was not built to leave the solar system. Almost no one was thinking that far ahead. It was built for a much shorter, much more modest job. Fly past Jupiter, fly past Saturn, send back close-up photographs of those two giant planets and their moons, then, most likely, fall silent as its systems wore out. The primary mission was expected to last around 5 years. That was the whole plan. A quick tour of the outer planets, a few years of glory, and then a slow goodbye. But the engineers who built it made a decision that would echo for half a century. They powered it not with solar panels, which are useless so far from the sun, and not with ordinary batteries, which would die in months. They powered it with a small nuclear device called a radioisotope thermoelectric generator. That name sounds complicated, so let me translate it into plain language. Inside Voyager 1 sits a lump of a radioactive metal called plutonium-238. Plutonium does something very useful as it decays. It gets hot, all on its own, with no moving parts and no fuel to burn. The generator wraps that hot metal in special materials that turn some of the heat directly into electricity. So the same glowing core does two jobs at once. It makes the power that runs the radio and the instruments, and it makes the warmth that keeps the fuel from freezing. Heat and electricity from one steady, silent source, pouring out every second of every year. When Voyager launched, that generator produced about 470 watts of electricity. That is roughly what a few bright household bulbs draw. Not much, but enough, because everything on the spacecraft was built to sip power rather than gulp it. And that little nuclear heart is exactly why Voyager 1 did not die on schedule. It cruised past Jupiter and returned images that rewrote the textbooks, revealing volcanoes erupting on a moon where no one expected them. It swung past Saturn and studied its rings in detail no telescope on Earth could match. And then, with its main mission complete and its systems still healthy, it just kept going. Outward. Away. Faster than any object humans had ever launched. For decades, it flew through the outer edges of the sun's territory. Then, in 2012, it did something no spacecraft had ever done. It crossed the invisible boundary where the sun's influence ends and true interstellar space begins. Voyager. 1 became the first human-made object to leave the bubble our star blows around itself and enter the space between the stars. The 5-year mission had become a 35-year journey. And it still was not done. But here is where the story turns. That same nuclear heart, the thing that made all of this possible, carries a countdown inside it. Because plutonium-238 does not stay hot forever. It fades. Every radioactive material has what scientists call a half-life. It is the time it takes for half of the material to decay away. For the plutonium inside Voyager, that half-life is about 87.7 years, which sounds slow, and it is, but slow is not the same as stopped. Every single year, the generator gets a little cooler and produces a little less electricity. The drop is roughly 4 watts each year. 4 watts does not sound like much. But remember, this is a spacecraft that started with only about 470 watts to begin with, and has been losing that amount year after year for almost half a century. Do the math in your head and the picture turns grim. The machine today runs on a fraction of the power it launched with. It is being slowly starved second by the same physics that once brought it to life. And no one can refuel it. There is no way to reach it, no way to add a single watt. The engineers can only manage what is left. So they made a choice that sounds almost heartless and turned out to be the key to survival. They began switching Voyager off, one piece at a time. First went the systems that were no longer essential. The cameras had already been shut down years earlier, once there was nothing left nearby to photograph. Then, as power kept dropping, the team started turning off the heaters. The very heaters meant to keep the instruments warm. This is the moment where the whole freezing problem comes roaring back. Turning off a heater in interstellar space means letting a part of your spacecraft get colder than it was ever designed to be. It is a gamble every time. And for years, the engineers were not sure the hardware could take it, so they tested it. Back in 2011, they shut off the heater on one of Voyager's instruments, a device built to operate no colder than about 35 degrees below 0 Celsius. With its heater gone, that instrument dropped to nearly 80 degrees below 0 Celsius, far colder than its rated limit. Cold enough, on paper, to kill it. It kept working. Think about what that tells you. These instruments, built in the 1970s, were tougher than anyone dared assume. Again and again, the team pulled the warmth away from a component, held their breath across the long hours it takes a signal to return, and watched the frozen machine keep sending data as if nothing had happened. One instrument kept running at 62 degrees below 0. Another, on Voyager's twin, survived being chilled far past its tested limit. Piece by piece, the engineers were performing a kind of controlled shutdown of their own spacecraft. Not to kill it, to keep it alive. Every watt they saved by letting one part go cold was a watt they could spend keeping the fuel lines warm and the radio talking. They were trading away Voyager's body to protect its heartbeat. And for a while, that careful, painful strategy worked. The spacecraft grew quieter, simpler, colder, but it lived. It kept flying, it kept reporting. Until one day in late 2023, without warning, Voyager 1 stopped making sense. For weeks, the spacecraft had been behaving normally. Then the data coming back turned to nonsense, not silence, which almost would have been easier to understand. Nonsense. The signal was still arriving on Earth, still strong, but the information inside it had collapsed into a meaningless, repeating pattern, like a voice reading the same broken syllable over and over. The instruments were fine, the radio was fine, but somewhere in the spacecraft's aging brain something had broken, and now Voyager 1 could no longer tell Earth what it was seeing or even how it was feeling. It was awake and confused, calling out across 15 billion miles in a language that no longer parsed. To fix a problem, you first have to understand it. And understanding anything on Voyager takes a punishing amount of patience, because of one number that shapes this entire mission. A radio command sent from Earth takes about 22 and a half hours just to reach the spacecraft. Then any reply takes another 22 and a half hours to come home. Send a single question, and you wait roughly 45 hours, nearly 2 full days, for the answer. Now imagine debugging a computer that way. You cannot see it, you cannot touch it, you type one instruction, then wait almost 2 days to learn whether it did anything at all. And the computer you are trying to repair is running on a design older than the engineers assigned to save it. Eventually, the team traced the failure to a part of Voyager's flight data system, the onboard computer responsible for packaging up information before sending it home. A single chip of memory in that system had died. And unfortunately, that dead chip held a piece of code the spacecraft needed to speak clearly. The corrupted memory was not something they could replace. You cannot send a technician 15 billion miles with a spare part. The code stored on that broken chip was simply gone, and the spacecraft could not function without it. So the engineers came up with a plan that borders on the unbelievable. If they could not fix the dead chip, they would work around it. They would take the lost code, rewrite it to fit into other, still healthy corners of the spacecraft's memory, and carefully update every other instruction that pointed to the old location so that nothing broke in the process. They were going to perform surgery on a 46-year-old computer, rearranging its mind from across the solar system, blind, with a 45-hour delay between every move. In April of 2024, they sent the first piece of relocated code up into the dark. Then they waited. Almost 2 days later, a reply came back down through the antenna on Earth. For the first time in 5 months, Voyager 1 made sense again. The signal carried real readings once more. Coherent information about the health of the spacecraft, flowing home from interstellar space, from a machine that had spent nearly half a year speaking in tongues. In the weeks that followed, the team moved the rest of the affected code to safety, and one by one, the science instruments came back online, measuring the space between the stars as if they had never stopped. A group of people on Earth had reached across 15 billion miles and rewritten the memory of a dying machine, and it had listened. Take a second and picture the moment that data came through, the room full of engineers who had inherited a spacecraft older than their careers, watching it wake back up. But saving Voyager's mind was only one front in the war. Because while they were fighting for its ability to think, another part of the spacecraft was quietly dying, the part that keeps it pointed at us. To talk to Earth, Voyager 1 has to aim. Its main antenna must stay locked on our tiny, distant planet, or the signal simply misses us and pours uselessly into space. Keeping that aim is the job of those small hydrazine thrusters, the ones with the fuel that freezes warmer than water. Over the years, the thrusters Voyager relied on to hold its position had been slowly clogging. Each tiny firing leaves behind a trace of residue inside narrow tubes, and after decades and countless firings, those tubes were closing up like arteries thick with age. If they clogged completely, the spacecraft would lose its ability to point, and the mission would end. There was a backup. In fact, there was an older set of thrusters, the primary roll thrusters that Voyager had used early in its journey. But those had been declared dead back in 2004, 21 years ago. A pair of small internal heaters that kept them functioning had lost power, and ever since, the team had written those thrusters off as gone, unusable, a closed door. Then one of the engineers had a different thought. What if the thrusters themselves were fine, and the original diagnosis had blamed the wrong thing? What if the real problem was something in how the power had been routed to those heaters, something that could actually be undone from Earth? It was a long shot with a terrifying downside. To bring the old thrusters back, the team would have to fire them, and firing a thruster that has sat frozen and unused for 21 years is genuinely dangerous. If the spacecraft's orientation had drifted too far, and those thrusters lit up while still cold, the sudden ignition could cause a small explosion. They might not save Voyager, they might destroy it, and they were running out of time to decide, because of a problem back home that had nothing to do with the spacecraft at all. Voyager 1 is so far away, and its signal now so faint that only one antenna on the entire planet is powerful enough to send it commands. It is a giant dish in Canberra, Australia, part of NASA's Deep Space Network, and it is known as Deep Space Station 43. That single dish was scheduled to go offline for upgrades starting in May of 2025, and to stay mostly dark until February of 2026. For most of a year, the one voice on Earth that Voyager could hear would fall nearly silent. If the clogged thrusters failed during that long quiet, with no way to send up a rescue, the spacecraft could drift off target and be lost before anyone could act. So the choice crystallized: revive the dead thrusters before the antenna went down, and accept the risk of an explosion, or play it safe, keep the failing thrusters, and gamble that they would survive the long silence. The team decided the greater danger was doing nothing. In March of 2025, they sent the command to wake the thrusters that had been dead for 21 years. Then came the wait. The long, familiar, nearly 2-day wait for any sign of what had happened out there in the dark. And when the data finally arrived, it showed something almost tender. The temperature of those old heaters had begun to climb, rising sharply within about 20 minutes of the command taking effect. The thrusters were warming. They were alive. The lead engineer on Voyager's propulsion later put it plainly. These thrusters, he said, were considered dead. It was just that one of their engineers had a hunch that maybe there was another cause, and that maybe it was fixable. A single insight tested across 15 billion miles had pulled the spacecraft back from the edge one more time. They had saved its mind in 2024. They had saved its aim in 2025. But there is one enemy the engineers cannot outthink, and it has been winning slowly the entire time. The power is still fading. And that brings us back to right now. In April of 2026, the team faced the same grim arithmetic they face every year. Not enough power to run everything. Something had to go, so they reached out across the dark and switched off another one of Voyager's instruments, a detector that had been counting charged particles in interstellar space. The small motor inside that instrument tells you everything about how far past its limits this machine has been pushed. It was built to click through roughly 250,000 steps over the life of the mission. By the time they shut it down, it had made more than 8.5 million. It had been running at 62 degrees below 0 Celsius. It should have quit long ago. It did not. With that shutdown, Voyager 1 is now down to just 2 working science instruments. One listens to the faint waves rippling through the thin gas between the stars. The other measures the magnetic field out there in the dark. 2 senses left, out of the 10 the spacecraft launched with. The mission manager described the decision the way you describe losing something you love. Shutting down a science instrument, he said, is nobody's preference. It is simply the best option they have left. And yet, even now, the engineers are not just managing the decline. They are still fighting to extend it. There's a new plan in the works, a clever reshuffling of how the spacecraft draws and spends its remaining power, that the team hopes can buy Voyager roughly another year of life. 1 more year. Enough, if it works, to carry the spacecraft to a milestone almost no one who built it expected to see. 50 years of flight. Because in the autumn of 2027, Voyager 1 will have been traveling for half a century, and it is about to cross another threshold that is hard to even hold in your mind. It is nearing the point where it sits a full light day away from Earth. A light day, the distance light itself, the fastest thing in the universe, takes an entire day to cross. That is how far one of our machines has gone. But make no mistake about where this ends. The power will keep fading. The instruments will keep going dark, one by one, until the last of them is switched off to save the radio. And eventually, sometime in the years ahead, likely in the early 2030s, there will not be enough energy left to keep even the fuel lines warm and the signal aimed. The engineers will lose the fight they always knew they could only delay. And Voyager 1 will finally go silent, still coasting outward, carrying its cold and quiet body into the dark for millions of years. When that day comes, it will not really be gone. It will just stop answering. So here's what I would ask you to sit with before that signal fades for good. Bolted to the side of Voyager 1 is a golden record, a disc carrying sounds and images of Earth, greetings in dozens of languages, music, the noise of rain and heartbeats and human voices, all meant for whatever might someday find it. It was our message in a bottle, thrown into an ocean so vast we will never see the far shore. And it is still out there, riding on that freezing, dying machine, long after most of the people who recorded those greetings are gone. That is the quiet truth underneath this whole story. Voyager 1 is going to outlive every one of us. It will outlive the engineers who saved it, and their children, and their children's children. It will keep falling through the dark for longer than our species has existed. A small piece of the 1970s wrapped around a nuclear ember, whispering home until the whisper finally stops. And for now, against the cold and the distance and the slow death of its own heart, it is still going, still coasting, still aimed at a pale dot it can no longer see, still transmitting, still measuring, still reaching for home from 15 billion miles away. The team on Earth is about to attempt that final power-saving fix, the one that could carry Voyager to 50 years. Whether it works, and how much longer this machine gets to speak, is a story still being written in real time. If you want to be there when we find out, follow along and stay with it. Some things are worth watching all the way to the end, because one day the answer will not come. The The dish will listen, and there will only be the hum of empty space. And on that day, something built by human hands, launched by people who simply refuse to stop reaching, will still be out there in the dark, still falling, still ours, still going.